Hello, we are going to take a look at the half angles formulas in these videos today. We will develop formulas for the sines, cosines, and tangent of a half angles. To derive the half angles formulas for sines, we start with the formulas for the cosines of a double angles that we made in the last sections. Now, if you let the theta equal to alpha over 2, then 2 theta equal to alpha. And our formulas will become cosines of alpha equal to 1 minus 2 sine square alpha over 2. We now solve for sines of alpha over 2. That is, we get sines alpha over 2 on the left of the equations and everything else on the right. Solving gives us the following sines of a half angles identities. The sines of alpha over 2, whether it's positive or negative, depends on the quadrant in which alpha over 2 lies. If alpha over 2 is in the first or second quadrants, the formula uses the positive case. If alpha over 2 is in the third or fourth quadrant, the formula uses the negative case. To derive the half angles formulas for cosines, we are using a similar process with the same substitutions of theta equal to alpha over 2. So 2 theta equal to alpha. We substitute into the cosines of a double angles. We obtain cosines alpha equal to 2 cosine square of alpha over 2 minus 1. We reverse the equations. Add 1 to both sides and divided by 2. Solving for cosines of alpha over 2, we obtain the half angles formulas for cosines. The sign is positive or negative of cosines of alpha over 2 depends on the quadrant in which alpha over 2 lies. If alpha over 2 is in the first or fourth quadrants, the formula uses the positive case. If alpha over 2 is in the second or third quadrants, the formula uses the negative case. To derive the half angles formulas for tangents, we may start with the basic definitions of tangents in the term of sines and cosines. That means tangents of alpha over 2 can be defined as sines of alpha over 2 divided by cosines of alpha over 2. We substitute their corresponding half angles formulas. That means this will be the half angles formulas for sine, and this one will be the half angle formula for cosines. We simplify it. We will get plus minus the square root of 1 minus cosines alpha divided by 1 plus cosines alpha. Therefore, we obtain the half angles formulas for tangents as this. The sines of tangents of alpha over 2, whether it's positive or negative, depends on the quadrant in which alpha over 2 lies. If alpha over 2 is in the first or third quadrants, the formula uses the positive case. If alpha over 2 is in the second or fourth quadrants, the formula uses the negative case. In the sines and cosines formulas, we couldn't avoid the square roots, but in these tangents formulas, we can. Let me show you how to derive the tangents of half angles as 1 minus cosines of alpha divided by sines alpha, or sines alpha divided by 1 plus cosines alpha. To write the tangents of alpha over 2 as 1 minus cosine of alpha divided by sine alpha, we may use the previous tangent of half angles. We multiply both numerators and denominator with the square root of 1 minus cosine alpha. We do the multiplication process for numerator and denominator separately, and we will have the following result. We notice that for the numerators, we can simplify as 1 minus cosine of alpha. And for the denominators, we may apply the Pythagorean identity to substitute 1 minus cosine square of alpha with sine square of alpha. Therefore, we will have 1 minus cosine alpha divided by square root of sine square of alpha. Again, we simplify the numerator square root of sine square of alpha as sine of alpha. And we will have 1 minus cosine of alpha divided by sine alpha. So, we can make a conclusion that tangent of alpha over 2 is equivalent to 1 minus cosine of alpha divided by sine of alpha. Furthermore, to write the tangent of alpha over 2 as sine of alpha divided by 1 plus cosine of alpha, we are using a similar process. Again, we use the previous half angle tangents identity. We multiply square root of 1 plus cosine alpha for both numerator and denominators. Again, we do the multiplication process for the numerator and denominator separately. We were going to have the result like this. We apply the Pythagorean identity for the numerators to substitute the 1 minus cosine square alpha with sine square alpha. And we simplify the denominators as 1 plus cosine alpha. Therefore, we will have the square root of sine square alpha divided by 1 plus cosine of alpha. Again, we simplify the numerator square root of sine square of alpha as sine alpha. And we are going to have sine of alpha divided by 1 plus cosine of alpha. Again, we can write the tangent of alpha over 2 as sine of alpha divided by 1 plus cosine of alpha. As a summary, these are the half angles identity for cosine, sine, and tangents.